Okay. All right, so this week is LO2 examples. If you recall, it seems like an eternity ago by now. But we did the same thing for LO1. We had a week of just examples way up here. I have it collapsed. Just examples. So the content for Learning Objective 2 is shut off. Like I presented everything that I need to present. You have all the concepts. We learned about objects, classes, references, the keyword this and how that works, constructors, inheritance, polymorphism, the state pattern. That's all the stuff that I need you to know. And this week is just helping reinforce those concepts and getting you to understand more of how the lecture content applies to the code that you're going to write, some tips and tricks of how to do that. Like today I'm going to spend a bit of time in the debugger and just getting you to understand the material better. So with that, when I do these review weeks, I have like what I think will help you out. I take common questions from office hours, for example, and try to address all those and just do what I think will help out, which isn't always the best thing, which isn't actually what's going to help out the most. So if you have questions more than most lectures, more than most weeks, if you have questions this week, please hit me up. The previous lecture had quite a few good questions in the chat in the lecture channel in Discord. So ask me questions, anything that's not making sense. This whole week is just to help you get through the homework, get prepared for the quiz, get prepared for the interview. Mostly the homework though. But I need to know what's holding you up. Like, where are you stuck? If you let me know where you're stuck, I can tailor the lecture towards that. And I don't mind getting off script if there's something that will help you more than what I have prepared. I'd rather talk about that than what I have prepared. Because it's not like I'm presenting new content where I have to get through everything. It's only what's going to help you. And if the 50 minutes of stuff that I have prepared won't help you, then let's talk about something else. Otherwise, by default, I'll just get on a script and just kind of start spouting out whatever I have prepared. So just keep that in mind. If you got questions, ask them. And if not, I'll just kind of do my thing of guessing of what I think will be useful. Which might not actually be useful, like I said. Let me get this back to where I had it. What did I even change in this class? Couple of things. Okay. And I'm going to go over the TV example. So last time we did a memory diagram with this TV example, but if you recall, I cut down some of the features. I just implemented a subset of the features in the code that I showed in Friday's lecture. So today I want to first go through the code of the full solution of how to implement every feature that was on that spec sheet, and then go through the debugger. The big thing I want to talk about is the debugger. But I'll spend a bit of time just going through this TV code with the state pattern. So we have the main method. This is exactly what we saw in lecture. This is the memory diagram that we built. We ran this program and talked about the entire memory diagram. In the TV class itself, we set up the state pattern. So we built a TV that has all the functionality that we were looking for according to that spec sheet. And when the TV's off, volume up, volume down, mute, don't do anything. You hit power, it turns it on. Then volume up, volume down work. You can mute to enter a mute state where the volume is 0. You can unmute. You can turn off the TV, etc. We had all these features that we implemented. To do that, we created a TV class, which is the only class we're going to test. By the way, we only access the TV class directly. Whoever's using, like if you have another developer and you say, hey, I built this TV class, it does these things, it has these features, that's the only class that other people care about. They're going to create a TV and hit buttons on the remote, simulate button presses in this case, and check if the volume is what they expect it to be. We're never going to access the state directly, and whoever's consuming this code, whoever's using this TV class, doesn't even care that you use the state pattern. It's irrelevant to them. The state pattern is how you built the functionality, but whoever's using it Like you might have used classes that are built into Scala that might happen to use the state pattern, but that's how they implemented it. It's not how you use the code. You're using the code just through the API. You're going to call these 5 methods on TVs, and it should do what you expect it to do. So we want to build this TV with all that functionality. We're going to apply the state pattern to build that functionality. When we apply the state pattern, usually, in our case, the TV, in your homework's case, the self-checkout, the TV is going to control the state of the object. So we have 2 state variables here, volume and max volume. One that's going to change the volume. For your self-checkout, this would be your cart, the items that have been added to the store. You have a lot of state variables that you've added to self-checkout. The state, when you apply the state pattern, will still be contained in the class that's having the pattern applied. So the TV is going to have some state, which it still controls, but the behavior of the object is going to be deferred to its actual state, whatever state it's currently in. So we have a variable that's going to contain the state of the class, in this case, a variable of type TV state, which initially contains a reference to an object of type off, meaning that this TV is currently in the off state. And then for all of the methods of the TV, all of its behavior, the only thing we're doing, we're not implementing any functionality. The TV class itself doesn't say anything about its behavior, but instead defers to its state. It says, hey, state, what's the behavior in volume up, volume down, mute, power, current volume, all our API methods. So we're going to defer to the state and say, hey, state, what do we do? And depending on the current type of the object referred to by that variable, that's going to determine what the behavior actually is at that point in time for that call. Oh yeah, it was asked in the previous lecture, but no, linked lists will not be on quiz 2. I answered in that lecture, but I don't answer things in chat also. But yeah, no linked list on homework 2. Also no, I said this last time, but worth repeating since it's the quiz and interview is upon us right now. The state pattern will not be asked on the interview. It will not be on the quiz. So just to reinforce, the state pattern isn't a learning objective of the course. Inheritance and polymorphism are. And I use the state pattern to give you more practice and more exercises with with polymorphism, which not extends. That's a terrible use of word. Polymorphism, which is enabled by inheritance. So the state pattern itself isn't something I need you to know. You need to use it to get through your homework, but it's only there to reinforce inheritance and polymorphism. For your quiz and interview, we're only going to ask about inheritance and polymorphism on those. The proper term's assessment, but I feel weird using that word. On those assessments. So the TA won't ask you about state pattern. Like I said last time, if a TA does ask you about state pattern directly on an interview, let me know so I can go yell at them, and then we'll adjust your interview grading accordingly. I just told them all in this morning's meeting that they should not be asking you about the state pattern. The only exception that came up was if you bring up the state pattern, then they might ask you a follow-up about the state pattern, is the only exception to that. But they won't ask you, they won't just come out and say, talk to me about the state pattern. Just keep that in mind. On the quiz, there's 3 questions because I know... Oh, my eyes. Because I know now the stack diagram take longer to make with all classes and inheritance stuff. I don't know if there will be enough time. So I have a few answers to this question. So there won't be 3 questions. I guess I can I leak how many questions? I didn't tell the previous lecture, so let me not. But yeah, the quiz will take a lot longer than LO1 quiz. I think of the best way to word this one. I just needed a second. So if quizzes are graded pass-fail, and there's no there's no hard and fast, you need to get this many questions correct or anything. That's all up to us on the grading side of whether your submission showed and demonstrated enough understanding of the material to warrant a pass and to warrant an application objective. So if we get all the quizzes back and 2 students were able to complete the quiz, that's easy for us to take care of on the grading side. We just kind of grade on a curve by saying, okay, the line for passing is getting 2 questions right, and the line for the AO is whatever we end up deciding. So if the quiz ends up being too long and you can't finish it and nobody finishes, it's we just handle that on the grading side. It's not that big of a deal. It's not the highest score, the max score of the class was an 80 because nobody could finish. Sucks to be. It's not like that in this class. If you demonstrated enough understanding, that's fine. So do the best you can on the quiz and don't sweat it. Anything else we'll take care of on the other side. That said, if you don't finish the quiz but 50% of the class did, that's a different situation. But you're not going to get screwed out of your credit. We're not going to set up a situation where you just can't win, you can't succeed. So yes, it will be a longer quiz, but don't panic. Would be my short answer to that. Any other questions about that? Because I know the grading is different in this class, that it can be confusing. Hopefully by this point in the semester that's pretty mitigated, but if there are questions about it still. All right, so the TV is going to control its state, but for its behavior, it's going to defer to whatever state it's currently in. And I know this is confusing. I overuse the word state quite a bit in this class. But what current state it's in based on its TV state, which is currently off, the off class is going to determine all of its behavior, but the TV is still going to control all of its state. So whenever one of these methods is called, we're just deferring to the state and saying, okay, in the off state, what does volume up do? In the off state, what does volume down do? And then once we have a state transition, we're going to have a state transition to the on state. At that point, all of the behavior is deferred to the on class. Well, however those methods are defined in the on class, that's going to be the new behavior of this TV. So the behavior changes based on the type of the object referred to by this variable of type TV state. So the variable is always of type TV state, but the object it refers to, whatever type that is, that's what's going to control the actual behavior of the TV at that point in time. So right now it's off, so all these methods get the off behavior. The TV state abstract class is going to define which methods can be called. Remember, through a variable of a certain type, we can only call methods access state and behavior. In our case, we're more concerned about the methods right now. We can only access methods that are defined in the type of that variable. So anything that we want to defer to the state for, we're going to define in the TV state class. So the TV state class is going to contain our entire API, which is these 5 methods. And in this case, I decided to not make any of these methods abstract. I have definitions for all of them, even though most of the definitions are do nothing. So this is an abstract method, equals, open brace, close brace. This is a complete definition of a method. Usually we would see this like this. We would see our braces, at least the code that I show you in class, would have this syntax. Since it's just open brace, close brace, and no body, to conserve space, I put them on the same line. So this is a full method definition. The method just happens to do nothing. It doesn't do anything. So for these 4 methods, they don't do anything. And for current volume, we're accessing the TV and returning its volume. This is what I call the default behavior for a state. So when I extend this class, when I inherit this class, those states will inherit these 5 methods. And if any state needs to do something other than this default behavior, it can override the methods that it needs to override. So if I want these 4 methods to do nothing, I just don't override them. If I want this method to do something other than return the TV's volume, I'm just not going to override that. And even though I have 0 abstract methods in this class, and I could absolutely validly do this, I can just have this as a concrete class because it has no abstract methods. There's no requirement that I make this abstract. But I'm going to make it abstract because it doesn't make sense to create a new TV state. I don't want anybody creating a new TV state, like saying new TV state. We can't create an instance of an abstract type directly like this. I don't want anybody doing that because it doesn't make sense for my TV to be in the TV state. It doesn't make sense to me. I want it to be in the on state, the off state, the mute state. So I'm going to make that abstract to prevent anyone from doing this thing that doesn't make sense, to just get all of the default behavior. I don't know, it doesn't make sense. TV state is just there to control my API. It's not there to be instantiated, to be able to create objects of that type directly. Yeah? When you first create the TV, yes, until we have a state transition. So like when we see the off state, in the off state when you hit the power button, we're going to have our first state transition, and we're going to access that TV's state variable. So this is this variable, and we're going to set that equal to an object of a different type. So we're going to create a new on object and then set that equal to that variable, and now the TV just transitioned to the on state from the off state. So initially it'll be in the off state, but then once we hit a state transition, we'll change its state. Can you explain the difference between question marks and... We also have this. This means unimplemented. Or not implemented, I guess. This means I have to implement this at some point. I know there's a subtle difference to this, but this is similar to an abstract method where I have to implement it at some point. Let me try. Let me try this and just see if this works. I think this breaks. And then I can give you a more solid answer as to why. Oh, no, it didn't. So I think there's a subtle difference between this and this. But both of those mean that this method has no implementation yet. And then it's up to us to eventually implement that method. Whereas this means this method is fully implemented. It completely exists and it's ready to be called. It just happens to do nothing. Would be the difference between those two. Bless you. And it's the weirdest syntax. But you can do that with variables as well. You can just say, this isn't implemented. Weird syntax. I forget the use case for that, but there is a use case for that where it actually is helpful. I forget off the top of my head what it is. All right, so in the off class, I'm fine with volume up, volume down, and mute doing nothing. I inherited methods from TV state for those. I inherited implementations that do nothing for those methods. And I'm okay with that. So I'm not going to override them. However, power, I don't want that to do nothing. And current volume, I don't want to return this TV's volume. So I'm going to override those two methods. Current power we just talked about, I'm going to override to have a state transition to the on state. And then, oops. Can't undo that. And then current volume, I'm going to override to return 0. Now, here's an important point here. With current volume, we might be tempted when we transition into the off state, we might be tempted to say this.tv dot volume equals 0. We might be tempted to say, okay, in the off state, the volume needs to be 0, so I'm going to set the volume to 0. It's a natural thing to do. Of course, if we weren't restricting to the state pattern and getting rid of conditionals, you'd be able to make this work. It'd be fine. You would remember. Let me back up a bit. So the problem with this, let me present the issue first, is when you go back to the on state, the TV should remember what volume it was. So if I turn the TV, I get a brand new TV, I turn it on, I expect it to be volume 5. I hit volume up twice, I expect it to be volume 7. I turn it off, and then I turn it back on, I expect the volume to still be 7. I don't expect it to go back to 5. When you're using a TV, you like setting it to whatever volume you like. You want it to stay that volume, and not every time you turn the TV on, okay, let me get it back to the volume I like. You don't want to do that. Always go back to the factory default. That's not how we're going to do it. We want the TV to remember what volume it was. So we can set this volume to 0, but we somehow have to implement something to remember what volume it was, and then replace the old volume with the new volume when it turns back on, go back to the stored one. We got some work to do if we do this. With the state pattern, we're going to still remember what the volume is. This variable is always going to be what the volume should be when the TV is on and not muted. That's what the volume will be. The TV will always remember that value right here in its state variable. And then when we're in the off, or for what it's worth, in the mute state, we're going to change the behavior of current volume to no longer access that variable. We're not going to access the TV's volume. We're just going to return 0. And then the volume can just always store what the volume should be when the TV's on and not muted. We're just going to change the behavior to not access that value when the TV's off or muted. And we're going to do that by overriding that default behavior. Instead of returning the volume, we're going to let the volume remember what it's supposed to remember, but just shortcut it and return 0 instead. When we transition to the on state, here you can see that second line that I was talking about. I tried to verbalize this. It'll be more helpful now that you can see it. The min and max, how we can use these to avoid some conditionals here. So I'm going to increment the volume by 1, and then set the volume equal to the minimum of the TV's volume and the max volume. Max volume is 10. So if I was already at volume 10 and I just incremented the volume to 11, math.min will take the min of 11 and 10. That'll return 10 and set the volume to 10. This is enforcing my maximum volume cap without using a conditional. And then volume down, same thing, math.max of the volume. So if this was -1 and 0, I'm going to set the volume back to 0 and not allow that volume to go negative. It'll very briefly be -1, but then the very next line is going to fix that, correct it back to 1 before, oh, it's not on here, but before current volume can ever be called, I'm correcting that to be able to be the correct volume with my max and min bounds. Now we are cheesing this a tiny bit, which I'm okay with on the homework, is in the min method, we are using a conditional. Since this is in Scala code itself, I'm okay with that. We don't have to worry about conditionals inside the Scala methods that you call, as long as your code that you wrote isn't being executed conditionally. So we are cheesing it just a little bit. And for what it's worth, this is Java code. The syntax doesn't exist in Scala. This is Java code. We're using the Java math class. We're in the Java laying package. Oh my goodness, get off my screen. And this is Scala syntax. Public final, class math. Class math is fine in Scala. Public final doesn't really mean anything in Scala. The constructor is defined differently. This actually has a private constructor for what it's worth. Interesting stuff. We can see E and pi defined here. Exactly what those variables are, things like that. But this is all Java code. We can use Java and Scala interchangeably. While I'm on the topic, actually, like get or else uses a match case state. statement, which is also banned. Of course, it's conditional. But I'm okay with that because it's in Scala code. So that's fine for the homework. And I get this question a bit. IntelliJ put question mark for you. Yeah, IntelliJ's not going to, I don't know how to respond to that. IntelliJ put question mark for me. So IntelliJ added the header for your method for you, and you also want it to implement the method for you. The question mark is IntelliJ saying, I don't know what you want this method to do, or replace these question marks with your actual implementation when you get a chance. How I'm navigating code. So this is a very handy thing to do. I use this all the time. And now that your programs are starting to get bigger, your homework 2 code, by the time you're done with it, will have quite a few classes, quite a few methods, a lot going on in it. To navigate that code, one thing that's very helpful, I'm on a Mac, so I'm going to hit Command, but on Windows it'll be Control. I'm going to hit Command, hold it down, and then click on a method call, and it'll take me to that method. So if you want to navigate your code a little quicker, something that I find very handy throughout my code. I'm going to do it again. I can get to the TV state constructor. You just saw me use it to get into math.min. Like, I'm not going to go through all of this crap. I shouldn't say crap, but all of this code that's part of Java. Like, this is all of Java down here. I'm not going to go through all that, find the math class, and then find the min method. I'm just going to command click it. And it's going to take me exactly to where min is defined. Can be very handy, especially if you are interested in how Scala and Java work under the hood. It could be really handy to get into those methods. Like you just saw, I just went into 2 separate methods defined in Scala and Java. It can be very handy to do that. Same with variables. I have this TV, and I don't see a variable named TV declared anywhere. I'm going to command click it. It's going to take me right to where that variable is declared. It's going to show me where it came from. It came from the TV state constructor. That became a state variable, and that's what I'm accessing there. State transitions, mute, power, goes to mute and off states. In mute, volume up, volume down, and mute, I'll unmute the TV. We have the feature where volume up and volume down don't change the volume, it just unmutes when it's muted. If we wanted to change the volume as well, we could add that code right here. We could increment, decrement, whatever. But from playing around with TVs, that's just not how the TVs I played with behave, so we're not going to build that functionality. But that's not to reduce the complexity of the code. I would just take this code, put it right here. Oh my goodness. And put it right here. Like, it's easy enough to add that feature. But that's just not how reality worked, so it's not part of our features. But that's going to have a state transition back to on. Power is going to turn the TV off. And current volume, just like the off state, is going to return 0. And every time we have a state transition, making sure that we pass a reference to the TV to that constructor. Okay, let me do a few things before to make sure I don't forget these, because I told the other lecture. So your TV, in this example, TV should store the state, all of the state variables that'll have values directly, and of course the state variable controlling the state. And the states themselves, pertaining to the state pattern, will have usually one state variable, which is a reference to the object to which it's controlling the behavior, for which it's controlling the behavior. It can have more state variables. So a common mistake that I see on the homework when you're first applying the state pattern is you go to your self-checkout, you copy all these state variables, you go to your, oh, it's not the one I was in, but oh well. And you go to your states and paste all those state variables. Generally, you don't want to do this. Those state variables, like these are going to change values, and presumably, like if you put your cart in your state, that's going to change values. You're going to add items to your cart, etc. But once you change states, once you have a state transition, these state variables disappear. They're attached to an object that you're going to lose the reference to as soon as you switch states. You no longer have a reference to your old state variables, your old states. Because when you have a state transition, you're losing your only reference to it and replacing it with a new reference. So we don't want to put state in here generally, but we can. We're allowed to. And for your homework, you're allowed to. For your homework, I don't even mention that you have to use the state pattern. In fact, you don't have to use the state pattern. Each semester I see a few students who will complete homework 2 without any state pattern at all. I maintain that it's much more difficult to do that. It takes some really advanced code. These are students who studied things beyond what we've covered in 115 and 116 that want to challenge themselves. So if you want the challenge, you can try to do homework 2 without the state pattern. It is possible. Much more difficult than just using the state pattern, though, in my opinion. Anyway, my point is, I don't even tell you you have to use the state pattern in the homework, which means you have complete control over how you design the state pattern. Complete control. You can do whatever you want for the state pattern, as long as you're not accessing your states directly from your test. That's the only restriction in your test. You're just going to stick to the API methods that were defined when you had the homework handout. You're going to create a self-checkout object, and then you're going to call those API methods and make sure the behavior is what you expect by calling display string and items in cart. As long as you're sticking to that, I don't care how you design your state pattern. I mean, I care. But you have full control, full creative freedom over how you set that up. What that means is if you want to, let me go back to on. If you want to create state variables here, if you want to create another state variable here, I can type. If you want to create more state variables, that's fine. You don't have to go just based on the structure that I've shown in lecture. If you want to deviate from that and create whatever you want, whatever state variables you want, go for it. Just keep in mind that these values, unless you do forward them to the next state, you could add constructor parameters here and just move these values from state to state. But these state variables are going to be inaccessible after your state transition. So I've mentioned before that when you have an API method that's going to do something different, you should think state transition. My example was 1, 2, 3, enter. After you hit enter, the enter button will do something else. It'll do a rescan instead of scanning the numbers that the user inputted. But somehow when you're in that rescanning state, you have to remember what that previous item was that you scanned. And it can get mind-boggling of how to do that. Maybe if you throw some more state variables, that'll be my hint for that. You can also add more methods, more classes, more packages if you want to organize your code. You have a lot of freedom in how you design this code. The only restriction is what you call from your test suite. That's the only restriction. Other than that, what you call directly, I should specify, directly from your test suite. Other than that, you have full freedom of how to design your code. The grader, when you submit to Autolab, will look through your zip file, unzip it, and look for every single Scala file and compile all of the Scala code in that submission that you made. So you can have any structure you want. You can really design however you would like. As long as your tests only directly call the API methods that were provided, that are defined in the document. But if one of these methods, like current volume, if current volume instantiates an object of a type that you created and calls 15 methods that you named, accesses 20 state variables that you named, that's perfectly fine, as long as you don't access those directly from your test cases. You have a lot of freedom. So adding methods, especially by the time you get to the application objective, adding more methods to classes where Like the item class, I say you need these methods. I think there's 4 of them, right? Price, tax, add modifier, and description. You have these 4 methods, but I never say you can't have a 5th or a 6th. You can add more methods and add more to this. Just don't call those methods directly from your test cases is the only restriction. Which even that restriction I'd like to get rid of, but I just don't see a feasible way for me to be able to write test cases for your code without, and for you to be able to write test cases for my code without having that restriction. But that's the only restriction. So keep that in mind. You have a lot of flexibility, a lot of power when you're writing these things. Get rid of this, and same thing with the previous lecture that took way longer than I anticipated. But let's get to some debugging. So the debugger, I gave a few demos of this, but I still get this in office hours quite a bit where I say, what happened when you ran the debugger? And the student looks at me and says, what's a debugger? So this will be the last time that I introduce the debugger. After this, when I use the debugger, I'm just going to jump in and use it without explaining how it works. But I understand that the last time I did it was during homework 1, and most of you probably got through homework 1 without really needing the debugger. Now that we're in homework 2, you're facing bugs where you're going to want some help that the debugger can provide. So I want to give another demo while it's more relevant. So the debugger, first I'm going to run my main method. I just run it. It should print out 0 and 6 like we saw in the memory diagram in lecture on Friday. It's going to compile 0, 6, yay. To run the debugger is already built into IntelliJ. This is part of why I like having IntelliJ set up for this class. You have this really powerful tool built right in. To run the debugger, it's just like running, except you run the debug instead. Or you click the debug here, or you right click. The debug button's always right next to the run button. I'm going to run the debugger. It's going to be super helpful. It's going to help me find my bugs and eradicate my bugs. And I ran it, and it didn't do anything. It just printed out 0 and 6. So to make use of the debugger, what we want to do is set what's called a breakpoint. I'm going to click right next to a line number. That's going to set a breakpoint, which tells the debugger that what the debugger is going to do is going to run your code as normal until it hits a breakpoint. Once it hits a breakpoint, it's going to hit the brakes, stop everything, and show you the state of stack and heap memory. It's going to show you all the information that we have on our memory diagrams and display it all to you, which can really help you find where that value is that isn't what it's supposed to be and try to figure out why that value isn't what it's supposed to be. I think if anybody coming to office hours would run through their code in the debugger first, I don't think there would really be office hours questions. You would find your bugs, run the debugger. I strongly recommend it. It can save you hours of time. And I say this because when I first learned the debugger, it saved me tons of time. I love the debugger. It saves me incredible amounts of time when I'm coding. And I found out about the debugger way too late. I was already in grad school. So I like showing you early, let you know what the debugger is. In 220, you'll be shown the debugger and you'll be encouraged to use it. I strongly recommend using it because it saves you time. It saves you tons of time. So I ran it, and it's going to show me, it stopped at my breakpoint, and it's going to show me the stack, and then all the variables that are on the stack, and whenever I see an at and some number, I know that that's a reference to a value on the heap. So we always have, every method call in Scala, we always have the keyword this, storing a reference to the calling object. Sometimes we don't care about it, in this case we don't, but the main method is a reference to the object from which it was called, TV main. We don't draw this for our main method, but for learning objective 2, every other stack frame that we have, every other method call that we have, we are going to explicitly put this on our memory diagrams. For LO1, it was the case as well. We just didn't care. I didn't care about the reference this because we weren't talking about objects and classes yet. Now that we are, we do care. But this is one we don't care about, and we still don't care about args. These are two things that you don't need to put on your memory diagrams. If you do put them on there, I'm all right with that, but you don't need them there. And let's go through my favorite buttons on the debugger. So my favorite button by far This blue arrow pointing down, step into. This is going to advance my code by one line, and if there's a new stack frame that's going to be added to the stack, I'm going to go into that stack frame. So we're about to go into the TV constructor. I'm going to click step into, and it's going to go into that new stack frame. We can see the TV constructor stack frame, and we have a reference to a new TV that's being created in the keyword this. So this is a reference to a TV. We happen to get the randomish, pseudo-random number 800. It's random to us, but I got the same exact number as I got in the previous lecture because there is some deterministic way of determining that. But we just don't care about that process. But we got 800 and room for the state variables that are going to be created. I'm going to click step into again. There's no constructor parameters here, no inheritance to worry about, so we're going to go right to the code outside of the methods. Volume equals 5. We're going to be able to see memory update on the heap as we run these lines. Max volume to 10. And then state is going to be a new off state. We're going to go into the off constructor. The off constructor is going to call the TV state constructor. And we have a reference in this to the off variable that is currently being created. I saw in the earlier run in this, we should have the TV as a state variable here. It does exist. It's there. I don't know why the debugger refuses to show it, but it is a state variable of the off class. We're going to enter the TV state constructor that's on the stack TV at 800. And as a state variable that's about to be assigned to TV, it's assigned, TV is 800, the constructor exits, we get that variable assigned to state, and we get that TV assigned to that TV that was returned, so TV is that at 800, and its state is off at 803. So this can be really handy when you're looking through your code and you're trying to figure out what state you're in. Some of the common bugs when you start task 3 and then the application objective are being in the wrong state, not the state that you expected to be in. Somehow your state transitions broke down and you didn't get to the state you wanted to be in. Well, with the debugger, I can see at any point in time what state my TV is in by looking at the type of the object stored in that variable. We get volume up. The TV, we're in the TV class, is going to defer to its state. State.volume up. This dot state is off. So we're going to look in the off class for volume up. We're not going to find it. So we go to its inherited method from TV state, which does nothing. It is just going to do nothing. But we can see our stack frames just like we did in the memory diagram in lecture. We have the main method, which called volume up, We have 2 volume up stack frames, and we can see all the values, which is just this, the TV at 800, this, the off state at 803. We can see those objects, those references to objects being passed along. So we get to see a lot of information when we run the debugger, all of the information that we could ever care about, and then some. Stack frame ends, we're back to the TV volume up. Stack frame ends, we're back to the main method. So that's by far my favorite button is the step into. It just advances one line of code. Sometimes we get into this situation. I see this tripping up a lot of students in office hours. We click step into. We get into a situation where Scala enters this state. It didn't advance a line, and it's asking us which method we want to step into. This irritates me a little bit. I wish the debugger would just go into the first method that's going to be called. Actually, I'm going to try this because it seems to be random behavior. I'm going to click step into again, and then it goes into print line. I don't want to go into print line. But I do want to get back to where I was. So I'm going to set another breakpoint. 248. I may have to redo this on Wednesday when I have more time to do it justice. But I want to go through the rest of the buttons. This resume. So I stopped at this first breakpoint, but I wanted to be at my second breakpoint. This is where I want to be. But if I don't want to get rid of this breakpoint, I'm going to click resume. That starts running through my code until I hit another breakpoint. This is very handy, especially if you're debugging something inside a loop. That can be very handy. You just keep going through the loop until you get to the instance that you care about. When I do get into this state, what it's asking me to do is click on the method that I want to enter. I want to enter my method, so I'm going to click on current volume, and that's going to enter the method that I care about. Once I get into a method that I don't care about, I change my mind. I don't want to be in current volume. I'm going to click step out. That's going to resume my code until the current stack frame ends. So I get out of that stack frame. Then finally, step over is going to skip a stack frame. If I don't want to enter into these methods, I'll step over them. And maybe I want to enter into current volume. I'll click step into again. So that was a little quick. I'll do more debugger on Wednesday. And with that, have a great day, and I'll see everyone. We'll see everyone Wednesday.